Today we are conducting a coding battle between three of the most powerful AI models: ChatGPT 4o, DeepSeek v3 0324 and Gemini Pro 2.5 experimental. I gave all three models the same coding challenge. First, visualize a double pendulum using physics and matplotlib. Second, build a simple Angry Birds game using Python and pygame. Let's take a look at how each model performed and what makes them different. Let's go! Prompt number 1. Write Python code to visualize a double pendulum using matplotlib and physics simulation. It's a great test to see how well an AI can handle differential equations, numerical methods, and animations. First, ChatGPT 4o, the recently updated model with improved capabilities for solving coding problems. It generated a very clean and compact code. Everything's there: equations of motion, ODE solver, coordinate conversion, and animation. The simulation runs smoothly, with no issues, but visually it's very basic. No axis labels, no time display, and the trial of the pendulum grows endlessly. So it works, but it's minimal. Next, DeepSeek v3 0324, 685B parameter, mixture of experts model, is the latest iteration of the flagship chat model family from the DeepSeek team. It took the same concept and made the visualization more complete. It added a grid, color-coded pendulums, axis labels, and even a time display on screen. The accuracy settings for the solver are more precise, which is nice. The code is slightly longer but still readable. One downside: the pendulum trail isn't limited in length, so it gets messy over time. And then Gemini Pro 2.5, Google's state-of-the-art AI model designed for advanced reasoning, coding, mathematics, and scientific tasks. At first glance, it seems like the best of all three. It's well commented, carefully structured, and includes nice touches like a legend, grid, time display, and trace length limit. The code looks very academic and presentation ready. But here is the twist. When I looked closely at the physics, I noticed something wasn't right. Gemini's implementation uses incorrect equations of motion. Both pendulum arms share the same denominator in the acceleration formulas, which breaks physical accuracy. So, while the animation looks nice, the physics underneath is wrong, and then really matters in a simulation like this. Verdict for double pendulum. Winner: DeepSeek v3 for combining correct physics with enhanced visualization. Now let's look at the second task. Prompt number 2. Build a simple Angry Birds game using Python and pygame. ChatGPT 4o gave me a simple working prototype. There is one bird, one pig, basic collision, and reset key. It's readable and runs well, but it's really just a starting point. DeepSeek went far beyond a basic prototype. It added multiple targets, scoring, hit points, and a win condition, but also different types of blocks and obstacles, each with their own health and behavior. There are collisions, bounce effect, and a reset mechanic. Gemini delivered a clean and visually polished demo. The launch mechanics are smooth, there is speed limiting, visual feedback, and even an automatic replay system. You can keep launching birds without restarting the game manually. ChatGPT 4o delivered a simple, functional prototype, clean but minimal. Gemini provided the most polished visual experience, but with limited gameplay. DeepSeek, on the other hand, added real game mechanics, multiple targets, obstacles, scoring, and a full win start loop. Verdict for Angry Birds game. Winner: DeepSeek v3 for creating the most complete and playable game. So here is the final verdict. For clean structure and polished visuals, Gemini looks the best. For actual physics accuracy, ChatGPT and DeepSeek are correct. And for gameplay and interactivity, DeepSeek wins hands down. You can find all the code examples in my Telegram channel, and don't forget to like and subscribe for more AI coding battles. See you in the next video.
Bye.